Let's take some time and finish and actually explain what's happening with these pictures. We had to stare at it a little bit yesterday and we didn't get very far. So we're trying to show that the sine of alpha plus beta is what that is. And so we've got angle alpha, which is from P to Q here, then angle beta, which is from Q to R. And you have this angle from P to R of alpha plus beta. And so that we stared at it for a while, we didn't get very far, and we had our opportunities. We were looking at some hints. So let's see what it says. First of all, we know it's a unit circle, which means I'm going to go ahead and mark some of the things that are 1 here. OR is 1, OQ is 1, and OP is 1. I'm not going to mark the other ones, just OR. And that's really helpful. And so what we know is that RS is the length of sine of alpha plus beta, which is what we're trying to find. And the reason it's the length is because this is 1, so it would be RS over 1, and so opposite over hypotenuse. And so it will just be RS. So I'm going to go ahead and label this. Actually, I'm going to use a much bigger picture because this one's a little small. So I'm going to go ahead and label this as the sine of alpha plus beta, just so that I have that, and of course that needs to be in parentheses. And I have that marked, and I've already got this marked as 1. That comes off our first one. And so we also know that these pieces over here are is the same length, and this is the same length. We're going to use this. So if we can somehow figure out what AB and BC are, we'll be all set. So that's what our goal is, to figure those out. So what I want to do is set up some relationships for alpha here. So I know that the sine of alpha is equal to BA over OB. And so that OB is times the sine of alpha equals BA. So now if I could figure out what OB was, I'd be set. So I'm going to stare at that triangle for a minute, see if I can come up with a length for OB. And sorry, I'm looking at some notes. So let's see. Let me go ahead and set up a relationship with beta. And let's go ahead and do beta. When I do beta, I'm going to do this triangle here, this with angle B being the right angle. So I'm going to look at that triangle. And so cosine beta is equal to OB over OR. Well, OR I've already marked in my picture as 1. So cosine beta is equal to OB, since OR is 1. So I'm just going to write that over here. OR equals 1. So in my picture, I can now mark this side, which I'm not going to leave green, but that's the side I'm marking, as cosine beta. And so let's see. I'm still looking for AB. Let me think about, oh wait, here I am. So OB right here, I figured out as cosine beta. And so that makes AB, this little side right here, this side right here, sine alpha times cosine beta, because OB is cosine beta. So I know that length. That's pretty cool. So I found one of the 2 lengths I need, because I know that the sine of alpha plus beta is equal to AB plus BC, and now I know AB is sine alpha times cosine beta. So I've got that, sine alpha times cosine beta. And so that's pretty cool. We can use that. Now I just need to figure out BC. So let's go back to this triangle. Let's look at BC and see what I can do. So I've used a couple of the hints that were given to me on my hint sheet, and I need to figure out what BC is. So right now I'm going to look at hint number 3, which says, how can we use trig to find line segment AB? I did that one. So hint 4, it asks me how the angles are related in the two triangles. So I'm staring at these two triangles here to try to figure out what's going on with some of my angles. So I've got this angle, well, and this angle right here, because of alternate interior angles, maybe not that angle. Hang on one sec. This angle, that's the one I was looking for. That angle is alpha plus beta. I'm not sure how that'll help. We'll get back to that in a minute. I think that's more helpful for the next one we're going to try to prove. But let me see, this triangle here, what is happening? Let's see what we got. So let me go ahead and write sine of beta. So sine beta is equal to BR over OR, and OR, if I recall, is 1. So sine beta is equal to BR. And so this length right here is sine beta. So let me write that. Sine beta. Okay. And you should be putting these things on your picture just so you know where we're at. So that's that. And how will that help me find BC? I'm still looking for that length. So, what is this angle right here? So this angle, I don't know what it is, but it's alpha minus 90. And if that's 90, this must be alpha. See, that's interesting. This is alpha. And I know stuff about alpha already because I know this side on alpha. Will that be helpful here? Not, well, maybe. What do I know about what I'm dealing with here? We've got sine beta. That's alpha. Yeah, let's see what we got. So let's go ahead and do the cosine of alpha in that little angle right there. So we haven't actually written cosine alpha yet, but we're going to use this triangle here to do cosine alpha. And so I'm doing this triangle here, but alpha. So we got cosine alpha equals the adjacent side, BC, over BR. And BR we just discovered was sine beta. And so BR, I'll just write that first, BR times cosine alpha equals BC. And BR is sine beta. So sine beta times cosine alpha equals BC. So that's this side right here. Sine beta times cosine alpha. And so what I know then, what I can do is, so this side, remember we know right here that A plus B, AB plus BC is sine of alpha plus beta. And we know BC, and we already had AB, we have the following statement. Sine of alpha plus beta equals sine alpha times cosine beta plus BC is sine beta times cosine alpha. So that's where that came from yesterday. I just showed it to you, but this is where it comes from. So that's what we were trying to discover on our own yesterday. So moving on, now that we know that, we can actually use that information to figure out this identity of what sine alpha minus beta is, and we can just use some algebra manipulation. So we know that sine of alpha minus beta is the same as sine alpha plus negative beta. So I'm going to just kind of rewrite the statement I just had. Sine of alpha times cosine of beta, but our beta is negative beta, plus cosine alpha times sine of negative beta And so, what is cosine of negative beta? Well, that's just regular cosine. That's one of our fundamental identities. The fact that cosine is an even odd function makes this just cosine beta. And then this one plus cosine alpha. And sine of negative beta is negative sine beta. So the negative sign coming out because it's an odd function. And then cosine times negative, so that's going to be a negative 1 here. Cosine alpha times sine beta. So instead of being plus in between, it's minus in between. That's a pretty quick derivation using what I know about the adding identity there. And so that's where we're going to leave this video. You're going to come back and watch another one about cosine alpha plus beta in just a minute. So I hope that helps you understand what was going on, and we'll see where we can pick it up in our next video. Thanks so much.